Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews and on-site training. In this episode, we're going to look at a potential way of tracking ABI changes that you've made in your code so that you know if you need to alert your users. So the project that we're going to talk about is abidiff, and this is a tool that is supposed to show you the ABI changes between two different binaries. So we're going to give it a try and see what we find. Okay, so we've created a new folder here to play with, and let's just make sure we've got abidiff installed. We do not. It looks like it is in ABI tools. I'm not using Debian, but this would be an interesting way to see what binaries are actually in here. Okay, ABI compat, ABI diff, ABI DW, ABI lint, ABI package diff, and KMI diff. Let's see if we can get this installed. Well, it looks like there's no easy way to install it on Arch Linux, so we will be getting the Git repository here and compiling it ourselves. Actually, maybe we should just download the latest package. All right, it compiled without any problems, and now we'll see what we have. Oh, goodness. Options, file 1 and file 2. There are many options here. We can give it header file information. We can tell it things to drop, things to keep, things that are harmless. It'll tell us that. Okay, so we have to clearly create a couple of examples. Now, of course, since this is C++ Weekly, I am going to go with C++, not C. I don't know if this tool is mostly designed for C or C++, or what the difference may be. I'm going to give const and non-const overloads here. This is going to be a simple struct. And actually, let's do something like this. Yeah, that seems good for the header file to me. I really don't know what kind of files it's necessarily going to assume that I have here. So we're going to, again, just have to test it out. Now, for the one that takes a single parameter, I'm going to go ahead and add an int to it. So that's definitely got to be an ABI breakage. I added a parameter, and I really don't know what these functions should do. All right, this is a pretty silly test. No main. So we're just going to compile to an object file and see if that's good enough for us to test against. Let's just start with this. Go back into our tools folder, and we're going to try this ABI diff between these two object files, which we believe should be the same. Okay, it did not report any errors, and it did not report anything. All right, so it's really not showing any changes at all, which is expected. Let's go ahead and start making changes and see what we get. Now I want this one to become const because we know that it ultimately should be const. And I made a mistake back on the previous example. I made it so the non-const version of this took an integer. Let's make sure that our headers match. And let's get rid of this one. So we know we've made an ABI breakage in the useParams function and in the change to the getX member function. Let's see if we get a diff reported now. Ah, here we go. So removed the function symbol not referenced by debug info. So I removed this thing. Now clearly this needs some sort of demangle action. Yeah, I don't see a demangle. So we're going to pipe this through C++ filth, which is going to automatically demangle these things. So we removed the function symbol not referenced by debug info. So we deleted the one that takes an int, and we added one that takes that doesn't take an int. So that is true, but it didn't track the changes for our member functions. Oh, I didn't properly define our member function. That would be related, wouldn't it? Now, defining it in line means that we're probably still not going to get it dumped in the binary. Yeah, so we're still not seeing that difference here, but I declared it in line. So let's make it out of line. Oh no, let's give it the header files for these two different versions. Still not getting it showing up here. Now I think that that's actually fair. At no point is that function actually being generated here. So it's not ending up in the executable. There we go. Now we see an entry for this getX function. GetX here. And note object dump has demangle support built in. So I do -C and I can get this getX. So let's try that diff again. All right, now we go. We see that we've got removed function symbols and added function symbols not referenced in the debug info. Let's go ahead and also add debug info to both of these and see what difference that makes in the ABI diff tool. Oh, well, that was interesting. Wow. Okay. So now with debug info, we actually get to see things like method and function used and not used, which makes me wonder if I need to pass this through C++ filth. Now, I don't need C++ filth anymore. Now it actually, interesting. It shows us the method and then the symbol name. That's great. We don't want demangling now anymore. So yeah, there you go. That's really interesting. So what other tools do we have now? We have a lot of tools. I wonder what this does. Oh, core dumped. Looks like they're not checking for a missing symbol name. Okay. Found a symbol, an instance of a function symbol type of weak binding. And symbol not found. So interesting ways to search through the ABI of your library. This has actually been a really interesting exercise here, trying to just play with this tool. If you're concerned about ABI compatibility, you need to really dig into these tools. Now this is libabigail, and you should be sure to check this stuff out because it looks like that there is plenty of info here. This is the kind of thing that you could roll into like your CI and alert you if you broke ABI and you're really concerned about that. And it doesn't look like it would be terribly difficult to work with once you get used to these tools. So I hope you enjoyed this episode of C++ Weekly, and you know, the usual, be sure to subscribe and give this video a thumbs up.